All right. We are now in 12.6, and 12.6 deals with adding and subtracting um, radical expressions. Now, if you remember when you had to add or subtract fractions, you didn't change the the denominator in the while adding or subtracting. So if you look at the examples here, like the one right here, where you have the fraction a over c plus b over c, um, that ends up equaling a plus b all over c. Same thing deals if you were to do subtraction. A over c minus b over c would end up equaling a minus b all over c. It'd almost be like if, for example, you had 3 over 4 plus 2 over 4. It would end up equaling 5 over 4. You didn't change the you didn't change the denominator in any case. Same thing like if you just had 3 over 4 minus 2 over 4, you would have this would equal 1 over 4. All you're doing is you're uh, adding or subtracting the numerator, and as long as both the denominators are the same, you can leave it as all you're doing is just adding or subtracting the numerator. Now, if you have two fractions that you're adding together that have different denominators, like you have the examples here and here, you have a over c plus b over d. What you have to do is you have to find a common denominator. And often, the best way to find a common denominator is to take the denominator in the first fraction and multiply it by the denominator in the second fraction. So then a over c plus b over d can equal, see how I have the common denominator of c times d? But what you have to keep in mind is if you multiplied a d to the denominator, then that means you have to also multiply a d to the numerator. Same thing goes with the second fraction. You're adding a c to both the numerator and the denominator. So if you do one set of either the numerator or denominator, you must do the same thing to both sides, and that will become very apparent when you start doing the examples in today's lesson, especially when you're doing your homework. If you look at, again, same thing with the subtraction. If you go a over c minus b over d, that equals AD over CD minus BC over CD, because what we're doing, like I said before, in addition, if we multiplied by both of those together, we must do the same thing as we did from the numerator and the denominator. Okay, let's go over some of the examples. So we're, for examples A and B, we are just trying to find the sum or the difference in our problems or in expressions. So if we have 2x over x plus 2 plus x plus 1 over x plus 2, I see that x plus 2, they share the same denominator. So I know for a fact that the denominator is going to be x plus 2. Now, as I look, I'm going to look at um, common um, like terms. I have 2x and I got an x. And I have the addition, so it's going to be 2x plus x, which then will give me 3x. And I got nothing that attaches to the 1, so it's just going to be plus 1. So my answer here is 3x plus 1 over x plus 2. And for B, I have 4x plus 1 over 5x minus x plus 3. So all over 5x. So common denominator is 5x, so I know my denominator is going to have a 5x on that. Now if I look, I have my like terms. I have 4x minus an x, which means that that's going to be 3x. And 1 minus 3 is a negative 2, so it's going to be minus 2. So my answer here is 3x minus 2 over 5x. Okay? And something to keep in mind is being able to find the least common denominator. The product of the factors of the denominator with common, let's see, product of oh, I see. It says product of factors of the denominators with common factors can be only used once. And I'll explain that through the examples. These examples are looking for the least common denominator of the rational expression. So all we are concerned with is the denominator in this case. I'm not asking you to solve or simplify these equations at this point. I'm just looking for common factors. So, or the least, or finding the least common denominator. I'm sorry. So, if I look at 1 over 12x, and then I have the other fraction as x plus 7 over 4x. So the only thing I have to concern with is 12x and 4x squared. Okay? So I realize that I can put 4 into 12, and I also can make x as an x squared. Oh, jeez. Screw that up. So, all right. So the least common denominator in this example is 12x squared. And the reason why it's 12x squared, which this is the answer. I'm not expecting this next portion here. I'm not expecting you to do this for this, but I'm just showing you why it's that way. So if I put 12x squared, comma 12x squared for these two values, the only thing that I added to this first equation is another x. So if I put an x on the bottom, that means I have to put it on the top as well. And for the second equation, the only thing I did to the bottom is I multiplied it by 3. So if I multiply it by 3 to the bottom, which means that means I'd have to do the same for the top. And that's where I got a least common denominator of 12x squared. Let's look at B. So again, I'm only concerned about is the denominator. So I have my x squared plus 4x minus 5, and then on the other one I got x squared plus 7x not minus, it's plus 7x plus 10. These can be reverse foiled. And if I go parentheses, parentheses, I got x, This -5 here means that they're going to be different signs. And it's going to be x plus 5, and it's going to be x minus 1. If I reverse FOIL here, I got x. That positive 10 means they're going to be the same. The positive 7 means they're going to be both plus. And it's going to be x plus 5 and then x plus 2. And so that's where this little green box here, where it says the product of the factors of the denominators with common factors only used once. So as you see, these ones share an x plus 5. So that means that you only have to write that once. So that means that my least common denominator for example B is going to be x plus 5, x minus 1, and then x plus 2. So that's what they mean by you only write them once. And looking at C, I got x minus 8 and then x plus 1 as my denominators. And since I really can't factor, do any type of cancellations, I'm just going to multiply those two together. So it's just going to be x minus 8 times quantity x plus 1. So that would be the common factor for example C. All right, so now that I've shown you how to find the least common denominator, and I'm showing you some examples of how to add and subtract radical expressions, here are the steps you need to do in order to find radical expressions with unlike terms. So first off, you have to find the least common denominator. You do that by what we did in those previous 3 examples in A, B, and C. Second thing you do is you rewrite each fraction with the common denominator, and then you multiply each numerator by the missing factors from the first denominator. Again, this is like whatever you do to the bottom of the fraction, you must do to the top. Once you do that, you simplify. And then, so let's add fractions over one denominator. Yeah, that means just keep them on the same. Keep the same denominator and then simplify the answer. Okay, so first off, I want to figure out what the least common denominator would be for 6 over x, or no, for 18x plus 4 over 6x squared. Okay, so if I have my least common denominator, I look at it, it is 18x squared. So if I go 18x squared plus was 18x squared, the only thing that I did to the numerator is I multiplied by another x. So that means on the top I have to multiply by another x. For the second fraction, what I did was I multiplied the bottom by 3. And since I multiplied the bottom by 3, I must multiply the top by 3. So 4 times 3 is 12. And this ends up equaling 6x plus 12 over 18x squared. And the last thing you have to do is simplify. And what I can do is I can factor out a 6 out of the numerator, which then leaves me with 6 times the quantity x plus 2, all divided by 18x squared. And now I can cancel this because this makes this a 1 and this a 3. So then my final answer would be x plus 2 all over 3x squared. Let's look at B. So B, first off, I'm going to try to find the least common denominator. And so all I'm going to pay attention to now is the denominator. So I have x squared minus 8x plus 15, and then I got x squared minus 2x minus 3. And those things can be reverse FOILed. So I got parentheses, parentheses, x, x. The plus 15 means they're going to be the same sign. The minus 8 means they're both going to be negative. And the values here will be 5 and 3. Here I got parentheses, parentheses, I got x, x, and it's going to be a plus and a minus because the negative 3 means they're going to be different. And it ends up going to be a 1 and a 3. And as you can see, these share x minus 3, so that means my least common denominator is going to be x minus 3 times x minus 5 times quantity x plus 1. Okay? So now I need to rewrite my fractions with our least common denominator. So both of them are going to have x minus 3, x minus 5, and then x plus 1, plus x minus 3, x minus 5, and x plus 1. Now, if we look, what we have to do is we must multiply the numerator by what we multiplied by the denominator. So here, in this first equation, we multiplied by additional x plus 1. So if we multiply by an x plus 1 denominator, we must multiply by an x plus 1 in the numerator. And in the second equation, so I got 2x plus 3, and I can multiply by, we added a x minus 5. So let's FOIL out both of our numerators. So if we were to FOIL out the first fraction in our numerator, we would have x squared plus 4x plus 3 divided by x minus 3, x minus 5, and x plus 1. Plus, and now if we were to FOIL out our second fraction in the numerator, it would be negative 2x squared plus 13x minus 15 all over x minus 3, x minus 5, x plus 1. And if we were to pair up like terms here, x squared minus 2x squared, which give me a negative x squared. I got plus 4x plus 13x, which gives me a plus 17x. And then I have plus 3 minus 15, which then gives me a negative 12 all over x minus 3, x minus 5, x plus 1. And that is your simplified answer. Got two more. So, first off, I have 5 over 2x minus 3x over x minus 1. Now, in this case, I can't FOIL or I can't factor anything out, so all I'm going to do is take 2x and multiply it by x minus 1 minus 2x multiplied by x minus 1. Just multiply them together. And by looking at the numerator here, I have 5, and the values that I added to it would be an x minus 1. So I'm going to multiply by that. And for the second one, I got 3x, and the value that I multiplied by the bottom was 2x, so I'm going to multiply by 2x to the top. So I did, so what I did to the bottom, I also did to the top to keep it balanced. So now that I have a common denominator, I'm actually going to distribute both my numerators. So I'm going to have 5x minus 5 over 2x times x minus 1 minus 6x squared all over 2x over x minus 1. And I don't see any common factors here, so I'm just going to rewrite this as negative 6x squared plus 5x minus 5 all over 2x times x minus 1. Last example. Is first off, I'm going to try to find the least common denominator. Just paying attention to the denominators in both fractions. So x squared minus 8x plus 15, and then I got x squared minus x minus 20. This can be reverse FOILed for both of them. This is parentheses, parentheses. I got x, x. That plus 15 means that the signs are going to be the same. The negative 8 means that they're both going to be negative. And the values will be 5 and 3. So the second one, I got parentheses, parentheses. I got x. The minus sign means that they're going to be plus minus, and the values will be a plus 4, and it's going to be a negative 5. And as you can see, I got negative 5 is the same, so that means my least common denominator is going to be x minus 5, x plus 4, and x minus 3. So now that I got x plus 3 as my first numerator, it's going to be x minus 5 in the denominator, x plus 4, and x minus 3, minus x minus 5, x plus 4, and x minus 3. And the value that I additionally multiplied in the denominator in this first equation would be the x plus 4. So I'm going to also multiply x plus 4 to the top of the equation. And I got x plus 6, which is original, and the value that I multiplied on the bottom was a x minus 3. So now what I need to do is I'm going to FOIL this out and then simplify. So for the first equation, my numerator FOILed out, it's going to look like x squared plus 7x plus 12 all over x minus 5, x plus 4, and x minus 3. Minus, FOIL this out would be x squared plus 3x minus 18 all over x minus 5, x plus 4, and x minus 3. And now we just combine like terms. X squared minus x squared is 0. 7x minus 3x is 4x. And 12 minus 18, or no, 12 minus a negative 18 gives me a positive 30 all over x minus 5, x plus 4, and x minus 3. And there you go. And that is how you solve by adding and subtracting radical expressions. Hope this helps. Until next time.